Okay, this is lesson 11.2. We are going to learn how to evaluate square roots using this note sheet. And the first thing you're going to do is label the diagram up here. This is the symbol that is typically a square root symbol if we don't have an index. Normally, you don't have to write the index for a square root. Basically, square root means you have two matching factors. So here's a question that might make sense. If you have to take the square root of 25, you're looking for the answer of 5 because 5 times 5 perfectly gives you 25. So a square root is always two matching factors that would give you this number. Sometimes we have what's called a cube root, okay, and you'll see this little tiny 3 drawn in. When they don't want two matching factors, they will tell you using this thing called an index. So you could label this as your index. They'll put a little number there, and what it means is now you're going to have 3 matching factors. So the cubed root of 8 would actually be 2, and that's because if you take 2 times 2 times 2, if you had 3 matching 2's, you would get the answer of 8. So cubed roots are a little bit trickier to think about. Square roots, you probably remember seeing those matching factors in your multiplication table in elementary school. So those numbers usually come pretty easily for us. Cube roots are a little bit trickier, but luckily I can show you how to use your calculator to help with those. So back to your vocab. Again, index, it's normally a 2 if you're talking about square root, but we're allowed to put a 3 or even a 4 or a 5 if we want to have more matching factors. The number inside is called the radicand. The whole thing is sometimes called a radical. And again, this is your radical symbol. It might look a lot like your long division symbol from elementary school. We're going to focus on perfect squares today. Perfect squares are numbers that can be arranged into a square shape. So the length of the side of the square ends up being that square root. So I guess we're going to start over here because that's the problem I gave you up here. The square root of 25 could geometrically be written this way. Inside my square root symbol, I have a 5, 1, 2, 3, 4, 5. I have a 5 by 5 square, and I'm pretty sure it's 5 units tall. So when you end up with a square that's 5 by 5, excuse me, it means there are 25 squares inside. The square root of 25, as we know, is 5, because again, the square design was 5 boxes this way, 5 boxes this way to give us the value. So let's look at a smaller square. This square only has 4 boxes this way, it has 4 boxes this way, and it creates a full square, so basically that means there's 16 in here. The square root of 16 then equals only 4, because remember, 4 times 4 is 16. This one has 9 boxes, so square root of 9 shows up as 3, and you can see the 3 boxes drawn to make that square have 9 units in it. Square root of 4 boxes would be 2, because again, 2 times 2, and square root of 1 equals 1. So luckily we do not have to keep drawing diagrams, but I believe this one has 6 going across, so that means there's 36 boxes in here. Square root of 36 is 6. This, I believe, has 7, 4, 5, 6, 7. Yep, so this has got a 49. 7 times 7, square root of 49 is 7. And I believe this one has room for 8 going across and down. So 8, let's see, that would be 64 boxes. Square root of 64 is 8, because again, 8 times 8. So remember, anytime you talk about a square, you're talking about a number that has an exponent of a 2. So down in this table, what I did is I had you go through all the numbers and square them so you can see 1 squared. The answers you get are called perfect squares. Okay, 1 times 1 is 1. That gives us a perfect value, just like we drew these squares up top. We could be drawing them again. But anyway, 2 squared is 2 times 2 or 4. 3 squared is 3 times 3 or 9. And I'll let you keep working. Pause the video for a second so you have the time. Remember, there's a button on your calculator you can push to quickly square a number. And if you'd rather, you could use your caret button with a 2 behind it to get that second exponent in there. So go ahead and pause the video for just a second. Try these on your own to fill in the rest of the chart. And then click play to check your answers. Okay, so here you have the rest of the perfect squares multiplied out. And again, take a second to check those solutions. Push pause if you have to. And then push play to meet me in the next section of questions. So on this side, I want to make sure that you know that you can approximate the value of a square root using perfect squares. For example, if you have to find the value of the square root of 20, know that it's got to be in between the perfect squares of 16 and 25. The square root of 16 is 4. The square root of 25 is 5, so you know the value of the square root of 20 is somewhere in between. Remember, we can find the square root button on our calculator. You would push the buttons second and x squared. And what should show up on your screen is the square root sign, even though it's a little short, and I believe they put a parenthesis bracket to hold the number that you're talking about. So if you would type that in, square root of 20, you are going to get a very long decimal, and it's important that you copy down all the digits given, okay, because this is your best approximation of the square root of 20. Now when I do this, I have approximately, so you can check it, I have approximately 4.47, and then it gives me lots of digits, as you know, because this number is irrational. We talked about irrational numbers the other day. Irrational numbers continue on without having any kind of pattern in them. So yeah, just make sure you also use an approximation sign so that we know that this really isn't the exact value of the square root of 20, but it's as close as we can get it. So this example down here, we know that square root of 7 must be between 2 and 3. We know the square root of 4 is exactly 2. And then the next perfect square is 9, and the square root of 9 is 3. So that's how I know 7 fits in between 4 and 9, and of course in between 2 and 3. So if you find the square root of 7 by, again, getting this on your calculator by hitting second x squared, the square root of 7 shows up as approximately 2.645. And of course there's more digits, so make sure you get them all, please. And sometimes we might want to round this off to the nearest tenth just to make it easier to work with, so it's approximately 2.6. And then we'll do a square root of 42. I have approximately 6.48. Again, lots of extra digits to jot down. And then this time they want us to round to the nearest hundredth. So nearest hundredth is 2 decimal places, so remember we're keeping the 0.48 this time. And again, if we were estimating to begin with, this is really close to the square root of 49, which I know is 7. And the square root of 36 is a little bit lower than 42, so I know the square root of 36 is 6. So I'm basically, guys, using this table right here as my guide, all right? I know that number 42, again, fits in between these two values. That's how I knew it was between 6 and 7. All right, flipping over to the back of your note sheet, I believe you have this. So the first thing you need to do is fill in at the top. A square root is a number that has an index of 2. So here's those symbols again. Square root of 1 we know is 1 because 1 times 1 is 1. Square root of 4 we know is 2 because 2 times 2 gave us 4. Square root of 9 is 3 because 3 times 3 is 9. And again, go ahead and pause the video. You want to take a minute to get the practice in using your calculator and to verify that you have all the correct solutions. When you're done, press play to continue with your notes. Okay, so if you notice the pattern I gave you here, I went through all the perfect squares, which basically gave you all the values of our counting numbers. It's important to notice that squaring a number and finding the square roots are opposites of each other, okay? The word inverse should fit in this blank, though, because I added opposite over here. Basically, understand that you can undo an exponent by using a radical. So if we square the number 3, like this example shows, that means 3 times 3 is 9. If I wanted to undo 9 and find the square root, this is what the symbol would look like. The square root of 9 means basically, how did you get that answer? Oh yeah, you multiplied 3 times 3. So when we ask you for the square root, we just have to state the number 3 for that answer. So the square root of 9, you get 3. When you square the number 3, you get 9. So try not to confuse the terminology here. This is squaring when there's an exponent of 2. Square root is the symbol right here. It is important that you know that technically square roots have 2 solutions. Because I can take 4 times 4 and get 16, but I could also take a negative 4, remember negative times a negative, and get 16, I stack my plus and minus sign together to come up with the square root of 16. So this row right here is just another example of how we could be taking negative numbers. Negative 1 times negative 1 is positive 1. Negative 2 times negative 2 is positive 4. So again, this is just another list similar to the one up here. Matter of fact, I think I'm going to grab all those answers and just copy it so I can bring it down here for you. The last thing to mention on this note sheet is just that normally what's called a principal square root, that's the positive value of square root. We typically don't have to work with the negative values. Distances can't be negative. So most problems you'll be dealing with the positive square roots. I think I got that in order now. So now that your notes are complete, again, feel free to come back, rewind, look at anything else. There's a nice kind of weird looking version. And your notebook. This is what it'll look like when you cut on the dotted line and tape into your book. Please see me with questions.